Assalamu alaikum everybody. This is Amir Khalil Houthi. Today I would like to introduce to you what are the various equipment, geophysical equipment we have in the Earth Science department. I give you a tour and talk about the various equipment we have and what are especially like some procedures you have to follow later on advanced courses whenever you try to use one of these equipments. Are you ready? So I'm entering the equipment lab. So the proposal for today is to acquire seismic refraction data. So those are the equipment I need ready for the seismic refraction data. If I give you a tower, we start from there. We have some advanced GPS system. Those are like very advanced. They are even the similar one used in the housing ministry. We have two of them. This is where we charge our batteries. If you come to this side, check the benches. We have some other seismic equipment. That's the old one. We'll be using a new one. Further we advance, so we find that we have some electric equipment. So why do we find here? We use this one to do seismic resistivity imaging surveys. This is, we use it for electromagnetic surveys. There are TDM equipment. Here we have electrical resistivity equipment. Those are the electrodes we dig to the ground. We have the geophones in this side. We have different types of geophones. Whenever I say different types, I mean what are the various frequencies limitation with them, or the natural frequencies of these geophones. For example, this one we use them for mass flow studies, or mass flow surveys. The one below here, the smaller one, and those are the one we'll be using today for the refraction. And they are cheaper actually than the one you find here. They're bigger in size, but the normal price I believe for this one is $200, whereas for the one below they are 100 probably for each piece. This is an example of seismic source. This was broken. We have another one. Use a better one than this one. We have also a plate. I will let you know what exactly, or how exactly we use the plate for refraction survey. For the advanced and forward, we will find two type of antennas. This is one. This is the big one is another one, but they are GPRs. So this is a GPR. So these are the GPR, ground penetrating radars. We have three types. This one, for example, has a frequency range of 400 megahertz. That's really high frequency. But usually the higher the frequency, the lower the depth of penetration. This is a lower frequency, so it goes deeper. It's heavier. It's more tedious job to work with this one than the smaller one. We have a medium range one there. We usually use that one for like a depth of up to 10 meters. This goes up to 2 meters, whereas this one investigation depth is about 20 to 30 meters. There are other factors we take into consideration whenever we talk about depth of investigation, either for like for GPR or any other geophysical equipment. So before we start our seismic refraction survey, I would like to give you some guidelines. Those guidelines are particularly for geophysics students because they will be taking advanced courses later on in their degree plan, and they will be requested or asked to make geophysical surveys, either seismic, gravity. The one you see here, for example, that's our gravimeter. So we'll talk about the gravity technique later on once we finish seismic reflection method. But whenever you'd like to access this facility, you need to get permission from our technicians. Mr. Saeed have good experience. Ask about him. His office is nearby. Ask about him or even Mr. Bedar. They are in charge of these equipments. They keep maintaining them, and whenever there is any problem with them, they do the maintenance. So ask for permission, and they are always happy to help you, guide you, support you, go with you even to the field. For example, there is a course we have called Field Geophysics course. In that course, usually Mr. Badr and Mr. Saeed, they come along with us, help us, guide us, do even after the field work, get us the data. They themselves, the data are saved inside those instruments. They get us the data, bring them to the labs, we do the analysis and interpretation. Assalamu alaikum again. So I arrived to the location we will do the survey for today. I think you recognize where am I right now. Let me rotate in 360 degrees. This guy, he's your colleague Ahmed Shidani. I'm very thankful to him. He came helping me doing the acquisition. Could you remove this cover for a while for them to see you?
Yeah.
Even the mask.
Hello.
This is Ahmed. There, back there, this is the mosque. I think this is Blocky, and that's the College of Science. Back to what we have. What are the various parts of equipment for seismic refraction survey? We have the main unit. This is the main unit, the yellow colored box. That's the recording system. We have a battery for power. We have what we call sledgehammer. That's the source. And we have two streamers. Each of these streamers can be connected to 12 geophones. So the total number of geophones is 24. What are the geophones, or where I can find the geophones? These are the geophones. So this is one, another one. I'm not sure why they call them strike. They are named strike. So this thing is a strike, and that's the geophone. It have a spike, and inside it's made of a coil rotating a magnet. The magnet is the inertia. Whenever there is a movement, the magnet moves, and a voltage is generated and get recorded. The voltage, the amount of voltage or the value of the voltage is linearly proportionate to the velocity of ground motion. And usually whenever we try to plant these things, we try to plant them vertically, and they should be firm to the ground without any. If you try to touch them and move them, you'll find they are not moving, or they are not loose. So this is how we plant them. Fortunately, the ground in here is a bit soft, so I can use my hand to plant the geophones. We have our equipment ready, things are ready. So the first thing, we have to make a plan. What is my profile orientation? Which direction I should make the profile? Because those geophones are supposed to be along a line, and the ideal orientation is the same orientation as the dip of the strata, subsurface strata. So usually we don't know how they are oriented. If there is some outcrop nearby, that might help us. So in this case, since I'm in a restricted area, there are a lot of trees. You see, I cannot make free movement here. I find that the ideal orientation probably is in this direction. That's the direction I probably take. And I try to extend them as much as possible to see what is the possible spacing between jufun. So these streamers you will find here, they have some takeouts. So this is takeout. This is where I connect my jufun with this cable. The spacing between one takeout to another takeout is 5 meters. So you cannot make your jufun interval more than 5 meters. So we made our plan that to make the interval between jufuns just 2 meters. This is a demo, it's not a real refraction survey, so 2 meters is an ideal case. We are just 2 persons, we cannot do much efforts. So the first thing after deciding that this is your profile, you lay down as what we have done here, a tape. This is a measuring tape. Along the measuring tapes, you have the distances. So we start from the beginning, that's where the 0 meter is, and we go up to 46. Why 46? Because 2 times 23 gives you a 46. That's the profile length. This is my profile. That's how it's oriented right now. So here I have 12 jufuns. I start planting them. Once we finish the planting, I come back to you. This is the start of the profile. That's the first jufun at 0. So I got 2 meters. Along the measuring tape, I'll find that 2 meters is exactly here. So I plant my jufun just here. That's how it's planted. The idea is here because this is one sensor. It's supposed to be vertical, very vertical. There is no tilting at all. The reason because the P wave moves in up and down direction, and our intention or our aim is to record the P wave, the energy coming from the P wave. So this is at 2 meters. That's how you do it in the field. The jufuns have been planted. We planted 24 jufuns. If I ask Ahmed to come closer and take a better shot along the profile direction, that's the profile direction. Spacing between the jufuns is 2 meters. I would like to say something is not related to the survey for today. And I emphasize on geophysics students, especially in their 5th year or 4th year probably, whenever they take field geophysics course. Mr. Saeed Labri and Badr Shakhsi, they will be marking you. They will be acting as evaluator for the course. And one of the conditions they emphasize on is early arrivals. We faced a lot of problems, students coming late, not exactly at like 7:45. We depends on drivers. Drivers don't wait for us to go to the site. If you are late, will not wait for you. Another thing Saeed emphasizes on is that you get the equipment ready. So you get the equipment yourself from the instrument lab, and you do all the job in the field. You do the acquisition, you do the survey, you do totally depend on yourself operating those instruments without any guidance sometimes from our sides. I might not be teaching the course again. I taught it last time. Here Ahmed is helping me again carrying the cables. We have 2 cables. Each cables accept 12 jufuns. The total number of jufuns is 24. So each one of them are connected or is connected to 12 jufuns. and the ideal position to put them is between Jufun 12 and Jufun 13. I'm almost in the middle of the profile. So these two will be put where Jufun 12 and 13 are. We finished the field setup. The Jufuns are planted and they are connected to the cable, recording cable, and the recording cable is connected to the recording instruments. I will show you later on where exactly the point of where exactly the instrument is located. But for the time being, if you get a closer look, you'll find that there is the source. This is the hammer, and beneath the hammer there is a plate. This is made of steel. It's a bit heavy, but the reason we use a plate instead of hammering the ground like that, we don't want the energy to be dissipated very quickly, making like a hole in the ground. So we hit the plate and let the energy moves down in a normal, in natural way, rather than in a plastic way. So you know, seismic waves are elastic waves. They are not plastic waves. What I mean by elastic and plastic, a plastic, whenever you break something, if I hit this thing, I make a permanent change in the ground. So I don't want to make that change. The energy is just dissipated, making this change. The energy is lost, making the ground being dug in a hole. Instead, I want to dissipate the energy, send it down in elastic manner or elastic fashion, hitting this plate. So hitting this plate. This is not a perfect hit. Ahmed might be doing it better than me, but the idea to show you where exactly is it. So this is the first Jufun. The first Jufun is here. It's connected to this cable. That's how the connection made. You will not make that silly mistake reversing the polarity, because they are of specific sizes. I cannot clip this one in the smaller area, so the red goes here and the black goes here. Common, intuitive, without getting into trouble. That's the first Jufun. The spacing between Jufun is 2 meters. You keep moving, you'll find there is a wire. That wire is connected to this hammer. Wire is connected to hammer. What's the importance of this? Because inside there is a trigger system. There is a system which tells the instrument there, the recording instruments, when to start recording. How it triggers, how the trigger starts. Trigger starts whenever I hit the ground. It has some sensitivity. So if the sensitivity, I can't change the sensitivity from there. If I make the sensitivity high, even probably my small such shaking trigger the system. So level your sensitivity to system that a hammer, hard hit makes that trigger, instead of probably simple shaking. Because I observed in the field sometimes with the students, they increase the sensitivity with the system, and they keep dragging the hammer, and the recording system start recording. So level out your sensitivity so it responds to hammerhead. Start recording when there is a strong hammerhead. So the setup is complete. The Jufuns are planted. The Jufuns are then connected to this cable, the recording cable. And if I ask Ahmed to come closer, get a better shot. So this is how the cables are connected. So you remember when I said there are two types of strings? This is the left one, this is the right one. they get connected to this jumper. They call it jumper. Not sure why they call it exactly jumper, but that's the name is. It's connected to the system. This is the system. This is a new equipment. It's the first time for me using it, but it's really nice. One of the things I liked about it is this joystick. You see, it can be controlled by this joystick. And the system is a Windows system. It's old system, Windows XP, but the system is nice. We'll get soon a closer look to the system itself. But when we connected them, so this is one connection. Another important connection is the battery. 12-volt battery. It's also connected to the system. Another thing is this one. What exactly is this? This is the hammer connection. So this is the trigger connection. It goes to the system, and the hammer can be extended to any location you desire. It can be hit in the middle of the array, that's the array. It can be hit on the far end of the array or beginning of the array. How I can decide which one is JUFON 1 or JUFON 24? The system decides. You can swap them in the system, but it's basically how do you connected them. So in the connection, it says which one is supposed to be 1 to 12 and which one is 13 to 24. And another interesting thing, because they are in recording stage, they are sensing any movement. In case I move right now, they feel this moving. If I hit the ground and ask Ahmed to come closer, you probably will notice that there is a shaking. There is a change in the amplitude. So another point I would like to emphasize on is, and it's actually delivered to me by Mr. Badr and Mr. Saeed, how important are those instruments? They are really, really expensive. The university is paying a lot of money getting this instrument to us. There's some noises right now, but never mind. So whenever you handle them, please take care of them. Take great care of them, because they are here for you to study, and once you graduate, your fellow students will use them again. And I'm already seeing some students, they are not using them properly and they are mishandling them, and we forced to buy new equipment, new cables, new JUFOs, and they are not that cheap actually. Usually the process of purchasing or asking for funding is a long process. It takes years and years. So please take care of them whenever you go to the field. Use them for the field, your project, final project, or your research. I'm in particular emphasize that point to geophysics students, because those are the ones who will be taking advanced courses in geophysics, either field geophysics or any course, or do their FYB project in any technique, either seismic refraction or other techniques in seismology or geophysics. So this is my system. I'm having the full control over the system using this joystick, the mouse I showed you. There are 3 windows. This is the display of noise. So if I make a shot or a noise, you'll find it's recorded. It's shown on some of the traces. So let me hit some of the JUFONs. Which JUFON is that?
This is JUFON number 11.
So I'm hitting right now JUFON number 11. Let's come closer and see what JUFON is this. 10.
10, yes.
So one side is the start part, or the starting side, starting from 1 to 12, and the other section from 13 to 24. In the lower part, it's an image of your survey geometry. So we see where the geophone 1 is. Geophone 1 is at a distance of 0, and the spacing between one geophone and another right now is 2 meters. And the last geophone 24 is here, and the hammer, you see the figure of the hammer is having an offset of 2 meters from the last geophone. So right now it's unhammered. I cannot make shots. How I make shots? I go to do survey, hit, arm it. When I click armed, the lower window, the geometry window, will have a green bar down below. The color changed to green, and it indicates that it's armed right now. And you'll find something called the stack. You see stack is 0. What we do in a seismic refraction acquisition, we hit the ground at the same location more than once. The reason is to increase the signal to noise ratio. So the more you hit, the better the higher the signal to noise ratio. But I say that there is a limit. You cannot keep hitting forever. Probably 10 or 8 is good limit. So I will start making some shots. This shot is at the far end, and I will show you the record. So I disarm it right now, and
Yes. Hit. Hit. Hit.
for today, this is for demonstration. We make 2 shots. The type of shot I made right now, it's called end off. Why it's called end off? Because it's at the end of the survey line, or at the end of the profile. We'll make a split spread shot too, hitting the hammer in the middle of the line or middle of the profile between geophone 12 and 13. When you start recording, let me know. Is it blue right now? So this is how it looks like. That's the final shot together. You will notice that the energy arrived earlier at geophone number 24. Why is that? Because the hammer is hit nearby geophone number 24, and that's exactly what you were given in the last lab or the practical I gave you, and you submitted yesterday. Yesterday was the deadline for the submission. Thanks to you, all of you have submitted. But this is exactly how we do seismic survey. An interesting thing in here, if I ask Ahmed to go to do survey, or shall I go myself? So this is do survey, and there is an option saying print record. If I uncover this part, you will find that there is a paper, and I hit this one. I get a hard copy of my shot gather. So this is how is it. Looks interesting. We'd like to make another shot. For this shot I would like to make it split spread, and I would like to have the shot location exactly at the middle of the spread. Where is the middle point of this spread? If I ask you, you cannot answer me because anyway, it's supposed to be between 12 and 13. So 12, if I multiply 2 by 12, I get 24. But since I'm starting from 0, 2 meter, 4 meter, and so on, at 12 it's gonna be 22. So this is 23. The middle is 23. How I change the geometry or the location? I go to something called geometry, and or here isn't can be done from do survey shot location. Yes, we clear the previous one because there is an option to save it if you are happy with your record. So if I go to do survey, I can save it. It's saved, made a sound, confirmed that the shot was saved, and I go change again the shot location. This will be cleared. So that's the number here. I go to this part, you will find there is a numpad or number pad. I simply type 23. This is 23. I confirm by pressing this arrow button. What happened? That's what happened. You'll see where the hammer is. It's in the middle between Jufun 12 and Jufun 13. When I'm ready to make a shot, I go to survey, do survey, arm it, arm the system, make the system ready for any trigger. It's converted to a green. It means I'm ready to make some shots. I will make 4 shots, quick shots, while Ahmed is recording me. So here am I in the middle of the survey, holding the hammer, ready to make 1 shot. This is Jufun 13 and that's Jufun 12. One, waiting signal from Ahmed.
Hit.
By the
Hit.
way, you have all the controls. How much should you wait between shots? So we made it 5 seconds.
Hit.
And we made the maximum 4 shots. I'm supposed to receive right now a shot gather. I ask Ahmed to record it. This is a split spread. This is quite interesting. So you see how it looks like. And let's print it. Let's make a print. I go to do survey, print. This is the process I think you are very familiar with because you do a lot of purchases from supermarkets. That's exactly what you get to here. I hope you enjoyed this virtual fieldwork. I will have some more virtual fieldwork. This is for seismic refraction The next one gonna be graffiti, and the other one will do for resistivity technique. Ahmed was very helpful to me. Thank you, Ahmed. And I probably ask him again to come and help me. Overall, that's how the seismic refraction is done. We made 2 shots for the data I give to you for the project or the lab. I already mentioned that in the last lab. I give you data and I give you also software to work on that data. But the number of shots in that case are 7 instead of just 2. Another thing, you see how the weather probably is today nice. It's enjoying weather. But usually we take this field geophysics course particularly, or other geological courses in the second semester, in the spring semester, and the weather is so hot. So take all your safety precautions, wear especially long sleeve t-shirts, get a good hat like that, a cowboy hat, maybe sunglasses too, and keep safe.